right, what we have here is a old quiz, and it has 12 questions on it. We're going to go through this and use it as extra practice for factoring. So here's the first one. Remember, we're basically doing FOIL backwards. We're trying to unmultiply this. It's like division, but you're kind of guessing the division, how it's divided up into two parts. So for example, if I have 15, I only have one way to split that up, and that's 3 times 5, and that's the only choice I get. If I have 12, see, I have choices. I can do 6 and 2 or 3 and 4, but the ultimate prime factorization would be 2 times 3 times 2. Well, that's what we're trying to do, is we're taking it and breaking it up into parts, but we're just breaking it up into 2 parts pretty much every time, unless we take out a common factor first. So here we go. We make our 2 parentheses on this one. So basically the way I want you to do this is you try the problem, and then and then hit play, and then you can watch to see if you got it right or not. So this is the first one. You can copy it down on a piece of paper and just do it with me, a couple of them, and then try it on your own. But basically, you want the 2 parentheses, you want x and x, because x times x makes the x squared. And now you got to think of ways to make 36. Well, 36 has several different factors. 1 in 36, so 1 times 36 makes 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So there's lots of choices to make that, but we're multiplying to make the last number, and we're adding and subtracting to make the middle number. So the only way to do that is with 9 and 4. Now notice that the 9 has to be positive, the 4 has to be negative, because 9 minus 4 is equal to 5. So let's go ahead and multiply. This is the answer right here, but let's go ahead and multiply it out to see what we just did here. So the whole purpose is to get this thing times this thing makes the original, just like this times this makes the original here. This is factoring too, right? This is factoring into the prime factors. So this is like like middle school, like, hey, we're going to do prime factorization. The reason why you do prime factorization like this is to reduce fractions, or to find common denominators. You can use the factors to build least common multiple or greatest common factors. Anyway, so we have this here. So I do x times x is x squared. This times this is negative 4x. This times this is 9x. This times this is negative 36. So I did first, like FOIL, right? First things multiplied together, outside things multiplied together, inside things multiplied together, last things multiplied together. First, outside, inside, last. And then you put these together, and you get the 5 in the middle, right? Because positive 9 minus 4 is the 5. So this is just me checking to make sure that it is correct. All right, so we got 12 of these to do. That was the first one. Okay, number 2. Four x squared plus 13x, and then plus 3. This one has a number in the front, so sometimes it's hard to know what to do with it. Is it going to be 4x and 1x, or 2x and 2x? Because you got to pick 2 things out that multiply together to make this. Now the 3 is easy, it's just 3 and 1, but it's going to make a difference possibly where it goes. All right, so try this one. And here we go. 4x and x is attractive. We put the 3 opposite the 4. That makes 12, and then 1 goes here. And plus is always plus and plus. In fact, that's a little chart for this. If your starting point has a plus and a plus, then it always is going to be factor into plus and plus. If it's minus and plus, it always factors into minus and minus. If it's a minus minus or a plus minus, then it factors into one of each sign. Okay, just like this one here, it was plus minus, so I had to have one of each sign in order to make the negative in the back and the positive in the middle. This one here, everything's positive, so it's just all positive. So I know that this times this makes this because I picked it out. I know 1 times 3. It's all about picking the middle part to make it work. And I use the Officer Bell half donut trick. Officer Bell is our resource officer here at the school. And this looks like a half of a donut. And I always ask the question, where's the other half of the donut? In Officer Bell's stomach, right? This and this make the 13, right? 1 and 12 make 13. So this is the answer right here. Okay. Number 3. 3 is 4x squared plus 20x plus 24. Now this one has a common factor in it. Remember the directions at the stop says, or the start of the top of this says, remember, check for a common factor first. And this has a common factor. If you recognize that and take the common factor out, it makes the factoring so much easier. So everything here is divisible by 2, but it's even divisible by something bigger than that. So go ahead and take 4 out, and then you're going to drop the 4 down, and then it factors a second time once that happens. So try this. And here we go. X squared divided by 4 would be 5. Divided by 4, 6. And then x and x. And this is a pretty easy one here. 2 and 3, everything's positive. 2 and 3 multiplied. Remember, you're multiplying like we did up here. Multiplying to make the last number, adding and subtracting to make the middle number. So 2 and 3. Oops. There we go. 2 and 3. All right, I'm going to pause this for just a second. Okay, now I'm back. Okay, number 4, this one also has a common factor to it, 2x squared plus 4x minus 6. So we're going to take a 2 out because it's the common factor, and then we're going to break it down a second time. Now, it doesn't necessarily have to factor a second time, but we'll see. And here we go. X squared plus 2x minus 3. X and x. So I divided everything by 2. And then there's a negative and a plus. So the 3 needs to be positive. 3 and 1 is the only choice I get for 3 since it's a prime number. And that, since that's positive in the middle, this needs to be positive and this needs to be negative. And if you multiply that out, it works. Number 5 is 4x squared minus 121. This one here, we have to recognize it as the difference of 2 perfect squares. So the difference of 2 perfect squares always factors the same way, and it's a something squared minus something squared is equal to something plus the something and then something minus the something, right? It always factors the same way. See, these are squares, like literally it's a times a minus, and then another square here, b times b, right? Subtraction of two perfect squares. So if I FOIL this out, a times a makes the a squared. This times this makes negative ab. This times this makes positive ab. And see, those are going to cancel out. And then this times this makes negative b squared. So the final result is a squared minus b squared, which is what I started with over here in the beginning. Because this goes away since they're opposite things. So you have to recognize this is a perfect square. It's 11 times 11. If you do enough of these, you start to kind of see these patterns. So we get 2x and 2x plus 11 and minus 11. It is the difference of 2 perfect squares. And that'll come up on here again. All right, number 6. Did I go too fast? Okay, there we go. Number 6. We have x squared minus 16x plus 64. When there's a plus in the back and a minus in the middle, it's two negatives. So there's your hint, minus, plus, two negatives. So we know that part of it. Okay, try it. Multiplying and adding for that. And here we go. So hopefully you paused and tried it, and then you can see if you got it right. That's kind of the idea here. That was my strategy. This is a perfect square. It's called a perfect square trinomial because you could rewrite this as x minus 8 squared. So there's some square out there in the world that exists that's x minus 8 by x minus 8. It's a square. So it's the same thing times the same thing, hence the term square. Number 7 is x squared plus 6x minus 27. Okay, so you got to think of the factors of 27. 1 times 27 and 3 times 9, and that's it. Well, it's got to be 3 and 9, so try it. And here we go. X and x. Plus 9 and minus 3. So then we check our work. We know that this times this makes the front and this times this makes the back. It's all about the inside. So 9x and then negative 3x. You put these together and you get the 6x. All right, so the answer's here. The answer's not the checking, that's the answer. And again, what are we trying to do? We're just taking something and breaking it up into two parts. Taking something, breaking it up into three parts. And in fact, we're going to take the next one and break it up into three parts. And this is we just did 7. Here's 8. Number 8 is 2x squared minus 32. So I'm going to take out the common factor first, and then it'll factor a second time. They don't all factor a second time, but this one will. So take out the common factor, and then try and factor it again. And go. I take a little sip of coffee in between so I can put a little space so you can pause it and try it. It is the morning. I'm really fresh in the morning. In the afternoon, Mr. Jackie's a tired Mr. Jackie. Okay, it's the difference of two perfect squares. So you can see that the middle goes away. There's no x term. There's just x squared and the 16. So the half donut trick here shows me that when I put these together, right, then I get nothing in the middle. Okay, we got all that. All right, here's number 9. Almost done. This one has a common factor. How do you know it has a common factor, you might ask? Well, even. They're all even numbers, so I can take out the common factor. It's not that way every time. Like the next problem, number 10 here, there's no common factor. It's like, oh, I can divide this by 4, I can divide this by 4, but that's 7. I can't divide 7 by anything except for 1 in itself, because 7 is a prime number. So we'll get to that one in a second. Okay, so divide 2 out, and then hopefully it factors a second time. Maybe it won't. Give it a little try. So we get x squared, 9x, and 20, and it does factor a second time. Do you see it? Pause it for a second if you need to and try it. Remember, you're multiplying to make this number, and you're adding and subtracting to make this one, and then 4 and 5 come to mind fast. All right, answer. So I guess this would be like this first one I showed you. I took 12 and I broke it down into 3 parts. 15 I broke into 2 parts. So it just kind of depends upon the quadratic, right? Okay, number 10, I kind of previewed this one. 4x squared minus 12x minus 7. Let's see. What should we do? I guess, we'll do, well, this other one was 4 and, it's not always 4 and 1. Let's see, we did one. Oh, this one was 2 and 2. Now, where's the other one with the 4? Oh, it's this first one here, this one back here. So it was 4 and 1, right? It was 4 and 1 to make the 4x squared, but it's not always the same. This is a good example of it, because this one here, your 4 and 1 would be a dead end. So try it with 2x and 2x. Oops, and here we go. The 7 here would make 14, and the 14 needs to be negative, and the 2 needs to be, or 1 needs to be positive, and the 1 needs to be positive. All right, so do you see it? Let's try without the half donut. So we chose that on purpose. We know that this makes the 7, right? So here's the center, so I'll cross these fingers. 2x, negative 14x, 2x, negative 14x, 2x, negative 14x, negative 14, positive 2, make the negative 12. Okay, number 11. 2x squared minus 11x minus 21. Let's see. 2 is a prime number, so we know it has to be 2x and x. So let's start off that way. Okay, give it a try. Okay, 21. Let's see. So 7, that make 14. 14. Okay, so if I put the 7 here, that's going to make 14. All right, 14. And then if I have 3 here, 3 and 14 differ by 11. The 14 needs to be a negative, and the 3x needs to be positive. All right, so this is the case where I showed you with the little sign thingy here. If it's positive, positive, it's 2 positives. Negative, positive is 2 negatives. And then here it's negative, negative. So when it's negative, negative, you have to have 1 of each sign. So this is the answer. Let's half donut this one just to check in, make sure we're right. Okay, so my whole point is you pick this on purpose to make the first thing. You pick this on purpose to make the last thing. It's all about, you know, putting the whole thing together. One of my students at the end of the day said, he's like, oh, so the first 2 things make the first thing, the last 2 things make the last thing, and all of it together makes the middle. Yes, that's exactly right. So I just bumped the camera so it went a little jiggly. Stop jiggling, camera. So this and this makes this, this and this makes this, put these together, all right, and it makes the middle. So the answer is right here. All right, number 12. This one compared to some of them is kind of a piece of cake. And now one thing is people go, oh, 2 and 3 make 5. But if you tried 2 and 3, it would be a dead end. So it's not 2 and 3. So try it. The reason why it's not 2 and 3 is because of the it has to do with the fact that it's a positive and a negative, so it has to be 1 of each sign. So it needs to be a positive 6 and a negative 1, because 6 minus 1 makes the 5. And that's the answer. All right, so hopefully this has been helpful. Some extra practice so you can focus, you know, by yourself. Try these without the distraction of people around you. You know, we basically went through this worksheet here. From if you're watching this out in the world, you can write them down with me or whatever. But for my students, I'll put this on Google Classroom. So if they want to print this off, they could do this on their own. All right. So happy factoring. All right. So there's my happy factoring face. So enjoy.